starting Unit 8 with the Pythagorean theorem. We'll be dealing with a lot of right triangles this chapter, ending up with non-right triangles, but a big chunk of it is right triangles, and one of the most famous things that we use with right triangles is the Pythagorean theorem. So that's what we're starting with today, using the Pythagorean theorem to calculate sides of triangles. And then if it's not a right triangle, we'll use the Pythagorean theorem converse to be able to tell whether it's obtuse or acute. All right, so here we go, the Pythagorean theorem. Simply put, the Pythagorean theorem is if C is the hypotenuse of a right triangle, so that's what we have to have, then here's the famous part, a squared plus b squared equals c squared. And so a and b are the two legs, and c would have to be the hypotenuse, the angle that's across from the right angle. Just one quick little proof of that. There's dozens and dozens. I think there's even 101 proofs, at least, because I once saw a book, 101 proofs of the Pythagorean theorem. But here's one way that you could think of it. You got A, B, and C, and so this square here would be, well, all of these would be C, and this would be another A, and this would be another B, and so forth. And so the area of this square could be thought of as, well, the area of this triangle times 4, since I have 4 of those triangles. So the area of the triangle would be A times B divided by 2. But we have 4 of them, so we'd multiply that by 4, plus the area of the square here in the middle, and that would just be c squared. So that's one way we could think of the area. The other way we could think of the area was simply a plus b squared. And, well, let's take a look at what happens here. When I use FOIL to expand this out, I get a squared plus 2ab plus b squared. And then over here, well, 4 and 2 would kind of reduce down to just be 2ab plus c squared. Well, notice that we've got 2ab, which cancels out this 2ab, and what we have left is c squared equals a squared plus b squared. So this is a pretty easy way to prove the Pythagorean theorem. All right, well, here is the converse of the Pythagorean theorem, in essence, which is, if a squared, so if a squared plus b squared equals c squared, then it must be a right triangle. So if I've been given the lengths of some sides and they wind up equaling, a squared plus b squared equals c squared, then I know it's a right triangle. Well, how can I use this if it's not a right triangle? Well, here's the thing. If a squared plus b squared, if c squared is greater, so c would be like the hypotenuse, this line right here. And if this is longer than it should be in order to be a right triangle, okay, so this gets longer, well then this makes it an obtuse triangle. And if you were in class, you saw a pretty good Geometry Sketchpad example of that. Well, the flip side is if a squared plus b squared, if what would have been the hypotenuse, if this is less than that, okay, if it's less than what it should be to be a right triangle, well then, so here is what would have been my right angle, just like this. Here is what would have been my right angle. Well, if this, what would have been my hypotenuse, is smaller than it should be, we can see how it closes down that right angle and makes it acute. And so this is how we're going to use, acute. This is how we're going to use the Pythagorean theorem converse in order to classify triangles. All right, so some quick examples here. Here we've got 8 and 15 as legs, x is the hypotenuse, so real simply we'll just say 8 squared plus 15 squared is equal to x squared. Make sure you always have the hypotenuse alone by itself there. At this point we say, all right, we got 64, 15 squared is 225 equals x squared. 64 plus 225 is 289 equals x squared. So x is going to be equal to the square root of 289. Now we told you in the previous day that we want exact square root answers. So we're going to start dividing this through by square factors and see if anything works. So if I divide it by 4, nope, I get a decimal. Take 289, divide it by 9, nope, still a decimal. 289 divided by 16, still a decimal. 289 divided by 25 certainly wouldn't work. How about 36? No. And it becomes clear pretty quickly. The square root of 289, well, actually, that's a square number in and of itself. So x is equal to 17. So there it is. All right, this point. Notice that this time we've been given the hypotenuse, and so we need to find one of the legs. So we set it up a little bit differently. We're going to say 10 squared plus x squared. The hypotenuse is 16, so 16 squared. 10 squared is 100 plus x squared. 16 squared is going to be 256. We subtract the 100 from both sides and we get x squared equals 156, which is definitely not a square number. So x is equal to the square root of 156. And again, we're going to go through, we're going to start determining whether or not we have any square factors. And it looks like we could split this up into the square root of 4 times the square root of 39. Now the square root of 39, you can't take any more factors out of when it's prime, or it's not prime, but it's prime factors. And so we'll just go ahead and say 2, the square root of 4 is 2 times 39, or square root of 39. And that's our final answer. All right, moving on. So here we've got a triangle, has side lengths 4, 9, and 12. Is it acute, obtuse, or right? Well, if this is a right triangle, we know that 12 would have to be the hypotenuse. 12 is always, or the longest side is always going to be the hypotenuse. So, first of all, how are these related? Well, let's say 4 squared plus 9 squared. How is this related to 12 squared? Well, 4 squared plus 9 squared is going to be 97. And 12 squared is 144. And so we would say that a squared plus b squared is less than c squared, or c squared is greater than. And so this means that the hypotenuse, quote unquote, is longer than it should be, so it's actually stretched out this 90-degree angle to be obtuse. So that's how we go ahead and classify those. And so make sure that you're showing your work to justify that, and that's how you would do that. Okay, here we got a little contextual question. It says, Reese leans a 12-foot ladder against the side of our house. So here is our house, and here is the ladder. So the ladder is 12, leans a 12-foot ladder. So the ladder in and of itself is 12. You can see that this would be making a right angle with the ground here in the house. The base of the ladder is 4 feet from the house. So how high on the house will the ladder reach? So this is what we want to determine. And once we see the diagram, we can clearly see how to put it together. We'll say 4 squared plus h squared is equal to 12 squared. 4 squared is 16. 12 squared is 144. Subtract the 16 from both sides, and we wind up with h squared is equal to 128. Now, the only occasion where you are not going to have to do an exact square root answer is if you have some sort of real life question. This would count for that. So h is going to equal the square root of 128, which is going to be approximately 11.3. And we're talking about feet. So make sure that you have a therefore statement, and we're good to go. All right, so there's your practice.